Close your eyes. Picture a room in Princeton, New Jersey. It is the mid-20th century. A study cluttered with papers. The smell of pipe smoke hangs heavy in the air. This is the private sanctuary of Albert Einstein, the inner sanctum. He sits there, wrestling with the unified field theory, trying to unlock the final secrets of the universe. But when the math becomes unbearable, he spins his chair around. He looks at the wall. On that wall, he kept 3 portraits. They were his patron saints of physics. 2 of them make perfect sense. You have Isaac Newton, the giant, the man who discovered gravity and calculus. Then you have James Clerk Maxwell, the Scottish genius who wrote down the equations for light. These are the heavy hitters, the establishment men. They were university men from Cambridge and Edinburgh. They had resources. No, they had pedigree. But then there is the third face. This one does not fit the pattern. He is not a professor. He is not a nobleman. He is the son of a blacksmith, born in a London slum. A man who never went to high school. A man who literally did not know enough math to do basic trigonometry. And yet, Einstein looked at him for inspiration. Michael Faraday. That is the mystery we are diving into today. How does a starving apprentice bookbinder, a kid surviving on a single loaf of bread a week, manage to rewrite the laws of physics? How does he invent the electric motor and essentially build the foundation of the entire modern technological world? It is a staggering question. Without Michael Faraday, the modern world as we know it does not exist. It is not an exaggeration. Erase his life from history, and the lights go out instantly. The power grid fails. The electric motors in your car, your computer fan, your refrigerator, your phone, they all vanish. We are thrown back to steam engines and gas lamps. Welcome to History Titans. Before we descend into the smog of 19th century London, make sure to like and subscribe to the channel. Join us as we uncover the unlikely giants who shaped our reality. Today we walk through the life of this titan. We have been digging through biographies, his personal letters, journals, and the records of the Royal Institution. We have analyzed his specific religious faith to understand what made him tick. It is a story of intuition over calculation. It is about seeing the invisible. But more than that, it is a story about character, about profound humility, and a specific kind of faith that drove him to find the truth in nature, no matter what the establishment thought. Let us go back to the beginning. To understand the heights he reached, you have to understand the depths he started from. The year is 1791, September 22nd. Newington Butts, now part of South London. It sounds quaint, but the reality was grim, truly grim. This was not the London of Jane Austen novels, with tea parties and carriages. This was a London of intense poverty, soot, and grime. The Faraday family had moved down from the north of England. His father, James Faraday, was a blacksmith. But James was a sick man. A chronic ailment meant he often could not even swing the hammer. And for a blacksmith, if you do not work, the family does not eat. It is that simple. Later in his life, Faraday remembered a specific time, the famine of 1801. The family was so poor that he was given 1 loaf of bread, not for the day, for the entire week. Think about that for a second. You are 9, maybe 10 years old. You are constantly hungry. Yet you must have the mental discipline to slice that single loaf of bread into 14 tiny pieces, 2 for each day. You know that if you eat a bigger slice on Monday, you will literally starve by Friday. That experience wires a brain differently. It installs a level of self-control and sheer discipline that most of us never learn. Formal education was a complete luxury, a non-existent one. He went to a local Sunday school where he learned the absolute basics: reading, writing, and ciphering, an old-fashioned term for basic arithmetic. Addition, subtraction. That was the sum total of his formal schooling. No geometry, no algebra, no science, no Latin. By all rights, Michael Faraday should have disappeared into the massive, anonymous laboring class of London. He should be a historical footnote at best. But he had a safety net, not a financial one, a spiritual one. The Sandemanians. This is the key to his entire psyche. You cannot understand Faraday without understanding the Sandemanians. They were a tiny Christian sect, an offshoot of the Church of Scotland. They were dissenters, not part of the main Church of England. In that era, that put you on the outside of polite society. Their beliefs were intense. They were literalists who tried to model their community exactly on the early Christian Church of the New Testament. They had no priests, no bishops, no formal hierarchy at all. They believed that every single person was equal in the eyes of God. That is a radical idea in Georgian England, where class and rank were absolutely everything. It was revolutionary. They placed all their emphasis on humility and community. They genuinely believed that worldly ambition, chasing medals, money, titles, or fame, was a sin, a distraction from God's work. So young Michael grows up in a dual world. On the streets of London, he is a nobody, the poor blacksmith's son. But inside the meeting house, he is a valued soul. He is part of a brotherhood that literally takes care of its own. That Sandemanian moral framework stays with him for his entire life. Be humble, serve others, tell the truth no matter what. He turns 14. He has to get a job. He cannot stay in school. He needs an apprenticeship. And this is the first major stroke of luck that changes the course of history. He becomes an apprentice to a man named George Rebo, who ran a bookbinding and stationery shop on Blandford Street. Bookbinding is hard work. It is a physical trade, stitching, gluing, pressing leather. But for Michael Faraday, it was a portal. It was a gateway, because he did not just bind the books. He read them. He read everything. He would stay late after the shop had closed, surrounded by stacks of books that rich people were paying to have bound, and he would devour them. He later called it his university, the Bookbinder's University. No tuition fees, just the smell of glue and endless curiosity. There were 2 books specifically that lit the fuse for him. One was a copy of the Encyclopedia Britannica. He opened it to the entry for electricity. We have to remember what electricity was back then, around 1810. It was mostly just parlor tricks. It was people rubbing amber rods with fur to make feathers jump around, or building electrostatic generators to give their friends a little shock at a party. It was not really seen as a serious, coherent science yet. It was chaos. But Michael Faraday read this long entry in the Encyclopedia Britannica, and he was hooked. He wanted to understand the order behind all those chaotic sparks. The second book was arguably even more important for him. Conversations on Chemistry by Jane Marcet. This is fascinating because that book was written specifically for women. The whole book is written as a dialogue between a teacher, a Mrs. B, and her 2 young female students. Because it was written for a non-academic audience, it was incredibly clear. It did not use jargon just for the sake of sounding smart. It explained the concepts from the ground up. For Faraday, who had no scientific background, it was a revelation. He read it and felt for the very first time that he could actually understand the physical world, that it was not some secret knowledge reserved for university professors. But he did not just read. This is the part that starts to set him apart from just being a fan of science. He became a practitioner. He took his tiny wages, mere shillings and pence, and he spent them on supplies. He bought cheap glass bottles and bits of lumber to build his own crude electrostatic generator. He bought chemicals from the apothecary. He started replicating the experiments he was reading about in the books. He was testing it for himself. He was proving to himself that what was written on the page was actually true in reality. Don't take anyone's word for it. Test it. So that became his method. There is something so pure about that. He is in some back room in London, essentially doing advanced physics, with bits of trash he found just because he had to know. But by 1812, the clock is ticking. His 7-year apprenticeship is coming to an end. He is 20 years old, and he is facing a lifetime of just being a bookbinder. And then a customer walks into the shop, a man named Mr. Dance, a member of the prestigious Royal Institution. He had noticed this bright young apprentice who seemed to care a lot more about the contents of the books than their leather covers. So he gave Faraday a gift, 4 tickets to attend the lectures at the Royal Institution. These were not just any old lectures. He was going to see Sir Humphrey Davy. We really need to set the stage on Davy. Today, unless you are a chemist, you might not know the name. But in 1812 London, he was a legitimate superstar, a bona fide celebrity. He was the poet-scientist. He had discovered a whole raft of new elements: sodium, potassium, calcium. He was handsome. He was incredibly charismatic. And his public lectures were the hottest ticket in London. It was entertainment. Aristocrats, socialites, and famous writers all crammed into the lecture hall at the Royal Institution to watch Davy perform. And perform is definitely the right word. He blew stuff up. He had this massive voltaic battery, the biggest in the world at the time. He would use it to create these blindingly brilliant arcs of light. He would make controlled explosions. It was absolute theater, but it was also cutting-edge science. And there, sitting way up in the cheap seats in the gallery, was Michael Faraday, just transfixed, completely mesmerized. But again, he was not just passively watching, he was working. He took meticulous notes. He developed his own system of shorthand. He wrote down everything Davy said. He sketched all the experimental apparatus. Then he went home and did something incredible. He took those messy shorthand notes and he expanded them. He wrote them all out again, in a clear, beautiful, flowing script. He added detailed watercolor drawings of the experiments, and then he bound them all together, because he was a master bookbinder after all, into a single 300-page volume. That is not a job application. That is a work of art. It is the ultimate cold call. He sent this beautiful book to Sir Humphrey Davy, along with a letter that basically said, "I want to serve science. Please get me out of the world of trade. I will do anything. I will wash bottles. It is a total moonshot." Davy was blown away. He could not believe this uneducated apprentice had understood his lectures so perfectly, maybe better than some of the aristocrats in the front row. He wrote back a very kind and encouraging letter, but he said, "I am sorry. There are no positions available. Science is a harsh and unrewarding career. Stick to bookbinding. You will make more money." That is just crushing. He must have been devastated. Faraday went back to work. He actually took a new job as a journeyman bookbinder, with a man he really disliked. He must have thought his one chance was completely gone. But then an explosion happens. Fate, or maybe chemistry, steps in. Davy was in his lab working with a chemical called nitrogen trichloride. It is an incredibly unstable substance, not something you want to mess with. It exploded in a glass vessel, and shards of glass flew into Davy's face. He was temporarily blinded by the accident. It was horrific. But he was a man who could not stop working. He needed a secretary, an amanuensis, someone to write for him while his eyes healed. He remembered the kid with the beautiful handwriting. He called for Faraday. It was just a temp job, just for a few days, a foot in the door. But Faraday made an impression. And then, a few months later, luck strikes for a second time. The permanent lab assistant at the Royal Institution, a man named William Payne, got into a fistfight in the middle of the lecture hall and was immediately fired. You cannot make this up. A brawling lab assistant opens the slot for arguably the greatest experimental scientist in history. It is pure serendipity. Davy needed a replacement right away. He offered the job to Faraday, but he warned him. He said, "Look, you are going to be paid less than you make as a bookbinder. It is dirty work. You will basically be a servant to science." And Faraday's response? "When do I start?" He did not hesitate for a second. So, March of 1813, he is in. He is finally a scientist, or, well, a chemical assistant, which really meant bottle washer, floor sweeper, and general dog's body. But he was inside the temple of science. He was learning every single day. However, almost immediately, things got very complicated. Davy decided to go on a grand tour of Europe. Now that sounds pretty great on the surface. A grand tour. Paris, Rome, the Alps. Intellectually, it was paradise. From 1813 to 1815, Davy took Faraday with him as his scientific assistant. They traveled through France, which was technically at war with Britain at the time, the Napoleonic Wars. But Napoleon gave Davy a special passport because he respected science more than politics. It is a detail I love. Yes, we are mortal enemies, but please come teach us about chemistry. Amazing. Faraday met the absolute gods of European science, André-Marie Ampère in Paris, Alessandro Volta, the inventor of the battery, in Milan. He saw their laboratories. He heard their arguments firsthand. It was a graduate education condensed into 18 months, but socially, it was a disaster. A total, unmitigated nightmare. Right before they left, Davy's personal valet refused to go on the trip because he was afraid of being captured by Napoleon. So Davy turned to Faraday. He said, "Look, you will have to act as my valet until we can find a replacement in Paris." That meant polishing boots, mending clothes, emptying chamber pots, and worst of all, it meant dealing with Lady Davy, Jane A. Priest. She was a wealthy socialite and a snob of the highest order. She refused to treat Faraday as a fellow human being. She saw him as a servant, plain and simple. Even though he was Davy's scientific assistant, she forced him to travel outside the carriage in the rain and the snow, while she and Davy sat comfortably inside. When they were invited to dinners with famous scientists, she would make Faraday eat in the kitchen with the scullery maids. That has to burn. Here he is, discussing the elemental nature of iodine with Davy in the morning, and then he is being treated like a peasant in the evening. It was deeply, deeply humiliating. Faraday wrote letters home saying he wanted to quit and come back to London. He was absolutely miserable. But this experience forged steel in him. He learned to completely detach his own self-worth from his social status. It reinforced his Sandemanian values. He saw that this high society world was cruel, shallow, and artificial. He decided right then and there he would never play that game. He would be a plain man of truth. They finally get back to London in 1815. Faraday survived. He settles into his work at the Royal Institution. For the next few years, he is basically Davy's shadow, becoming a master chemist in his own right. But then, in 1820, news breaks from Denmark. Hans Christian Ørsted, a Danish physicist, makes a discovery that shakes the entire foundation of physics. He found that if you run an electric current through a wire and hold a simple magnetic compass needle near it, the needle moves. To a modern listener, that sounds underwhelming. The needle moved. So what? You have to put yourself in the mindset of 1820. Before this moment, everyone thought electricity and magnetism were two completely different, unrelated forces, like light and sound, totally separate phenomena. Ørsted showed for the first time that electricity created a magnetic effect. They were connected. This set off a scientific gold rush. Every scientist in Europe starts trying to figure out the nature of this connection. They are all trying to figure out the math, and they are all failing. Why? Because they were all thinking like Newton. They thought all forces had to work in straight lines. Attraction, repulsion, a push or a pull. They were looking for a force that radiated straight out from the wire, like heat from a fire. But Faraday did not know the advanced math. He could not do the calculus required to model those straight-line forces. So his weakness became his greatest strength. He could not calculate, so he had to visualize. He used his imagination. He looked at the experiment and thought, the needle is not being pulled to the wire or pushed from it. It is trying to go around it. He saw a circle. He imagined a circular force swirling around the wire, like a little invisible tornado of magnetic energy. He decided he was going to build a device to prove that this circular motion was real. September 1821, the invention of what we now call the homopolar motor. It is elegantly simple. He took a small bowl and filled it with mercury, a liquid metal that conducts electricity. He stuck a bar magnet upright in the middle of the bowl. Then he dangled a stiff copper wire down from a stand so that the bottom of the wire was just dipping into the pool of mercury. The wire is free to move. Then he connected a battery. The current flowed down the wire, through the mercury to the magnet, and back to the battery. The instant he closed the circuit, the wire started to move, but it did not move toward the magnet or away from it. It started to spin. It spun around the magnet, round and round, continuously, or dancing. It was the first time in human history that electrical energy had been converted into continuous mechanical motion. It was the very first electric motor, the great-great-grandfather of every single motor we use today. The fans, the drills, the Tesla, the blender in your kitchen. It all starts in that little cup of mercury in 1821. The scientific community was stunned. Here was this uneducated lab assistant who had solved the problem that the greatest mathematicians in Europe could not crack. But this incredible triumph almost immediately led to a personal tragedy: the scandal. Faraday was so excited and honestly so naive that he rushed to publish his results. But in his haste, he did not give what was considered sufficient credit to the other men who had been discussing similar ideas with him, specifically a man named William Hyde Wollaston, and implicitly his own mentor, Humphrey Davy. Davy did not take that well. He was furious. He essentially accused Faraday of plagiarism. It was not true. Faraday's insight into the circular motion was completely unique, but Davy felt betrayed. He felt his own creation was starting to outshine him. There is that famous quote where someone later asked Davy, "What was your greatest discovery?" And Davy, to his credit, replied, "Michael Faraday." But by 1823, the mentor-protege relationship was toxic. When Faraday was nominated to become a Fellow of the Royal Society, the absolute elite club of British science, Davy was the president, and Davy actively tried to block his election. He tried to stop him. He went to Faraday and told him to withdraw his nomination, and Faraday refused. He said, humbly but firmly, that he could not do that as his friends had put him forward. The vote went ahead. Faraday was elected by a landslide. There was only one single vote against him. It is almost certain that it was Davy. It is such a sad end to that mentorship. The jealousy just seemed to consume Davy. Because of this bitter conflict, Faraday basically stepped back from research into electricity for the better part of a decade. He did not want to keep poking the bear, so we enter what some biographers call the quiet decade, the 1820s. But he was not sitting on the couch, not at all. He just pivoted. He poured all his energy into chemistry. He became the director of the laboratory at the Royal Institution. He did groundbreaking work on improving optical glass for telescopes. He did some of the first systematic research on alloys of steel. And in 1825, he made another massive discovery: benzene. He was analyzing this oily, sludgy residue that was left over at the bottom of the tanks of gas used for lighting the streets of London. He distilled it and isolated a new compound he called bicarbonate of hydrogen. We call it benzene. It is everywhere now. It is the fundamental ring structure of almost all organic chemistry. If you look at the molecular diagram of aspirin or nylon or plastics or dyes or TNT, that benzene ring is the basic building block. Just this one discovery would have made a normal scientist famous for life. For Faraday, it was a side project. He also did some wild experiments with gases. Liquefaction. It was known that steam could condense into water, but everyone thought gases like chlorine or ammonia were permanently airy. Faraday had the insight that they are all just vapors of liquids with incredibly low boiling points. He figured if you squeeze them enough and cool them down enough, they will turn back into liquids. And he proved it with chlorine. There was a funny story about a dirty test tube. A visiting scientist, Dr. Paris, saw Faraday working on this sealed tube containing chlorine hydrate. He noticed some oily-looking drops inside. He made a snarky comment. "You really should learn to clean your equipment properly, Michael." It was condescending. Faraday did not say a word. He just picked up a file. He scratched the end of the sealed glass tube to release the pressure. The so-called oil instantly and violently vaporized into a cloud of yellow chlorine gas. Mic drop. He sent a note to Dr. Paris the very next day. "Dear sir, the oil you were good enough to notice yesterday turned out to be liquid chlorine." You get a bit of a quiet sass to him. But this decade was also when his personal life settled down. He got married. In 1821, sure the same year as the motor, he married Sarah Barnard. She was a fellow Sandemanian, which was very important to him. This marriage was the absolute bedrock of his life. They never had children, but they were deeply devoted to each other. Inseparable. They lived in a small apartment in the attic of the Royal Institution for 46 years, literally living above the shop. But Sarah understood him. She understood that his scientific work was not just a job. For him, it was a form of worship. Let us dig into that. Today, we often hear the narrative that science and religion are enemies, that you have to pick a side. Faraday did not see the world that way at all, just the opposite. For Faraday, doing science was a religious act. His Sandemanian faith taught him that God was a rational, single creator. Therefore, nature, which is God's creation, must also be rational. It must be unified. It must follow a coherent set of laws. So finding a law of physics is like reading a page from the mind of God. This specific theology gave him a massive intellectual advantage. The Sandemanians believed profoundly in the unity with God. So Faraday believed in the unity of nature. He would look at electricity, magnetism, light, gravity, and chemical forces, and he would say to himself, "These cannot possibly be separate, disconnected things. They must all be different manifestations of one single universal force." That is a huge conceptual leap. It was revolutionary. Most scientists at the time were reductionists. They were happy to put things in separate boxes with different labels. Faraday spent his entire life trying to prove that the walls between those boxes did not exist. He was hunting for a grand unified theory long before anyone had coined the phrase. That hunt brings us to 1831. Humphrey Davy has passed away. The path is now clear. Faraday goes back to his first love, electricity. He wants to solve the inverse of Ørsted's discovery. Ørsted had shown that moving electricity creates magnetism. So Faraday asks the beautifully symmetrical question, can moving magnetism create electricity? It seems like it should. But he spent years trying and failing. He put powerful magnets next to wires. Nothing. He put wires inside strong magnetic coils. Nothing. But then in August of 1831, he builds a new piece of apparatus, the famous ring coil. It is a simple ring of soft iron, about 6 inches across, like a big, thick donut. On one side of the ring, he wraps a long copper wire and hooks it up to a battery. On the other side of the ring, he wraps a second, completely separate wire and hooks that one up to a galvanometer, a sensitive meter that can detect an electric current. The idea is simple. Turn the battery on. Current flows in the first coil. That magnetizes the iron ring. The magnetic ring should then create a current in the second coil. He is there with his assistant. He closes the switch. The battery turns on. The needle on the galvanometer jumps, but then it immediately drops back to zero. The battery is still on. The iron ring is still a powerful magnet, but the current in the second wire is completely dead. He is baffled. He scratches his head. He opens the switch to turn the battery off, and suddenly the needle jumps again, but this time in the opposite direction. Wait a second. He only gets a pulse of power when he turns the circuit on, and another pulse when he turns it off. That was the incredible aha moment. He realized that a steady static magnetic field does absolutely nothing. To create electricity, the magnetic field has to be changing. It has to be moving, or growing, or collapsing. The key was not magnetism. The key was change. This is induction. Electromagnetic induction. The fundamental principle behind the entire global power grid. Faraday realized that if change is the key, then he needed to create continuous change. So he built another machine. He took a simple copper disc and mounted it on an axle so he could spin it between the poles of a huge magnet. As long as the disc was moving, or as long as it was continuously cutting through the magnetic influence, a steady electric current flowed. He invented the generator, the dynamo. Before this moment, electricity was a scientific curiosity that came from batteries that would die in an hour. After this moment, if you can spin a wheel using a steam engine, or a windmill, or a water wheel, you can create limitless, continuous electrical power. It is really hard to overstate the importance of this. This is the moment humanity unlocks the modern energy age. And true to his character, Faraday did not patent it. He did not try to make a penny from it. He published the paper for everyone to read, and then he moved on to the next question. There is that great story that the Prime Minister visited the lab and saw the spinning disc and asked, sort of dismissively, "But what good is it?" And Faraday replied, "Why, sir, there is every probability that you will soon be able to tax it." It was incredibly prescient. But notice the timeline here. This is 1831. It took another 50 years of engineering development by others before this became practical on a large scale. The Savoy Theatre in London was the first public building in the world to be lit entirely by electricity. And that was not until 1881. Faraday was long dead. He planted the tree knowing full well he would never sit in its shade. But all this intense work, this decade of non-stop discovery, took a terrible toll on him. By the end of the 1830s, he just crashed. He had a complete mental and physical breakdown in 1839. Severe vertigo, debilitating memory loss, utter exhaustion. He had to stop working entirely for several years. So he went to Switzerland and just walked in the mountains for months, trying to reset his fried nervous system. But he did come back. In the 1840s, he enters his most visionary phase, the architect of the invisible. This is where he gets really profound. He is obsessed now with the nature of empty space itself, and he wants to prove his ultimate unifying theory, that light itself is a form of electricity, always searching for that unity. So in 1845, he sets up another brilliant experiment. He takes a piece of heavy lead glass, a special type of glass he had actually invented years earlier for a failed project. He puts it in the field of an extremely powerful electromagnet. He shines a beam of polarized light through the glass, and when he turns on the magnet, the light twists. The Faraday effect. It was the first ever physical proof that light and electromagnetism are connected. That light is an electromagnetic phenomenon. But it led him to an even bigger, more abstract idea. He started thinking about the space between the magnet's poles. Everyone else at the time thought it was just empty space. But Faraday said, "No, it is not empty. It is filled with invisible lines of force. We have all done the experiment with iron filings on a piece of paper. You sprinkle them over a magnet, and they magically arrange themselves into those beautiful curved lines." Everyone else saw that as just a curious effect. Faraday believed those lines were physically real. He believed the energy was not located in the magnet. It was stored in the invisible field of influence that surrounded it. This is the birth of field theory. It is arguably the single most important concept in all of modern physics. Everything is a field. Gravity is a field. Electromagnetism is a field. The Higgs boson is an excitation of the Higgs field. It all starts with Faraday refusing to believe in Newton's spooky action at a distance. But he could not do the math to prove it. The mathematical physicists of his day mocked him for it. They said his lines of force were vague, unscientific, childish nonsense. Until a young Scottish physicist named James Clerk Maxwell came along. Maxwell, the second face on Einstein's wall. Maxwell was a mathematical genius, and he looked at Faraday's diagrams and realized they were not only correct, they were perfect. He set about translating Faraday's pictures into the language of differential calculus. So the four famous Maxwell's equations that govern all of light and electricity are really just the mathematical translation of Michael Faraday's physical intuition. That is such a vindication. Maxwell himself said that Faraday was, in reality, a mathematician of a very high order. He just did the math with his imagination instead of with symbols on a page. Before we move on to his public life, we have to mention the cage, the Faraday cage. In 1836, Faraday wanted to prove that electric charge resides only on the outside surface of a conductor, so he built a cube. It was a giant wooden frame 12 feet on each side, and he covered it in copper wire mesh and tinfoil. He had literally built a room, and then he stepped inside it. He had his assistants charge the outside of the cage with a powerful high-voltage generator, artificial lightning, Green sparks were flying everywhere. It must have looked absolutely terrifying. And Faraday is sitting calmly inside on a wooden chair holding a delicate electroscope. The needle does not move. It registers absolute zero. Not a tremor of electricity made it to the inside. He proved that the conductive mesh shields the interior completely, which is why we are safe inside an airplane or a car during a lightning storm. And it is why your microwave oven does not cook you. That little mesh screen on the glass door is a Faraday cage keeping the microwaves in. So we have clearly established he is a genius of the highest order. But he was not some recluse locked in his lab. He was a very active public servant. He felt a profound sense of duty to the nation. For 30 years, he was the scientific advisor to Trinity House, the body that ran all of Britain's lighthouses. He spent years designing better ventilation systems for the oil lamps, because the moisture from combustion was freezing on the glass in winter and dimming the lights. He probably saved countless ships and lives just by figuring out how to properly vent a lamp. And he got involved in the pollution crisis of his day, the Great Stink. Oh, the River Thames. In the summer of 1855, the Thames was essentially an open sewer. The smell was so overpoweringly foul that Parliament had to soak their curtains in chloride of lime just to be able to function. Faraday was disgusted. He wrote a famous letter to the Times. He described going out on a boat, tearing up pieces of white card and dropping them in the water. They disappeared from view within an inch of the surface. He used data to shame them. His public letter was one of the key things that finally forced the government into building London's modern sewage system. He also investigated deadly mine explosions, the Haswell colliery disaster in 1844. 95 men and boys were killed. The official explanation was a pocket of flammable gas. Faraday went down into the mine himself. He looked at the scorch marks, he looked at the dust, and he proved that it was the fine coal dust itself, suspended in the air, that had been the primary fuel for the massive explosion. Did they listen to his findings? No. The mine owners said it would be too expensive to implement the safety measures he recommended, like dampening the dust. It took another 60 years, and thousands more deaths before the industry finally adopted his safety recommendations. That failure broke his heart. And then there was the Crimean War. The government came to him with a very different kind of request. They asked him to lead a program to develop chemical weapons, poison gas. And what did he do? This is where the Sandemanian faith draws a hard line. He told them essentially, I can do it. The chemistry is not difficult, but I will not. He refused on purely ethical grounds. He would not allow the laws of nature he had uncovered to be used for the mass killing of human beings. As he got older, the world tried to shower him with honors, knighthoods, presidencies, medals, and he turned them all down. He politely refused a knighthood from Queen Victoria. He turned down the presidency of the Royal Society not once but twice. He insisted that he wished to remain plain Mr. Faraday to the end of his days. Why? In his Sandemanian belief system, accepting worldly titles and power was a form of vanity that was corrupting to the soul. His reward was in the discovery, not the applause. The end of his life was quite sad. The memory loss came back with a vengeance. It was severe. By his 70s, he could barely remember his own greatest discoveries. He would walk around his lab looking at the equipment and could not remember what it was for. There is a very strong modern theory that he was suffering from chronic mercury poisoning. Think about it. He spent decades working with mercury, heating it, putting his bare hands in it for the motor experiments. The very thing that made his first great discovery may have been what slowly destroyed his mind. He literally gave his mind for his work. Prince Albert, Queen Victoria's husband, stepped in to help him. Faraday had no money. He had given most of what he earned to the church and to the poor over the years. So the Queen provided him with a grace and favor house at Hampton Court, a beautiful home where he could live out his final years in peace. And when he died in August of 1867, there was one final controversy, the question of where to bury him. The scientific establishment, the nation, They wanted to bury him in Westminster Abbey, next to Isaac Newton. It is the highest honor that Britain can bestow. And what was Faraday's wish? He had left very strict instructions. No. He refused the Abbey. He wanted no part of the pomp and circumstance. He was buried in Highgate Cemetery, in the simple, unadorned dissenter section, under a plain stone marker. Just his name and dates. There is a memorial plaque for him in the Abbey now, near Newton's tomb. But the man himself is buried with his people, which is exactly how he would have wanted it. It is perfect. So let us bring it all the way back to where we started, back to Einstein's wall. Why Faraday? After all of this, what was it about him? I think Einstein, more than anyone, recognized a kindred spirit. A man who saw the universe not as a collection of separate parts, but as a single, unified, beautiful whole. A man who trusted his physical intuition more than the accepted mathematical dogmas of the day, and just the sheer scale of the gift he left us. The motor, the generator, the transformer, the very concept of the field, the vocabulary of chemistry, ion, electrode, anode, cathode. He did not just add a chapter to the book of science. He opened up an entirely new volume. He unlocked the door to the modern age. But he did it with a grace and a humility that we so rarely see. He proved that you do not need a fancy degree or a privileged background to change the world. You just need relentless curiosity, iron discipline, and a willingness to look at nature with open eyes and say, "Show me the truth." A true titan, the architect of the invisible. So now I want to turn this over to you, listening at home. We have covered the motor, the generator, field theory, his chemical discoveries. If you had to pick just one of Faraday's contributions, the one that you think is the most essential, the most impactful for our lives today, which one would it be? That is a tough question. Are you team generator or team field theory? Let us know what you think in the comments. And if you enjoyed exploring the life of this incredible blacksmith's son, make sure you hit that subscribe button for History Titans. We have got some amazing profiles coming up on the people who built our world, and you really will not want to miss them. Share this with a friend who loves a good underdog story. Thanks for joining us. Goodbye.